All right, so in your Algebra Nation books, you are on page 38. We are starting inequalities today. Let's review what those are. You do know what they are. If I give you a number line that has like a circle on it and an arrow, we have inequalities. They show more than one answer. It's not just x equals 2 for this. We have a variety of solutions that could fit a certain problem, and these are inequality problems. So looking at this, is my dot or circle right now, is it an open or is it a closed circle? Open. This one is an open circle, yes. So this is an open circle, and it's open because the number represented by that circle is not part of my solution set. So if it is open, it's not filled in, then I'm not including that answer in my solution set. So looking at this number line, where is the line going? Right. It's going to the right. So are all of those values bigger or smaller than 2? They're all bigger than 2. So do we agree all the x values on the number line are greater than the number 2? Yeah. All my x's are greater than the number 2. Did your teachers ever do like the alligator thing? Yeah. It always eats the bigger number? Yeah. So all of the x's are bigger than 2. Notice there's a big piece and a little piece of an inequality sign. The little point points towards the small number. The bigger part faces the bigger number. Notice it's also pointing the direction of the number line. You see how my greater than sign is kind of like pointing over to the right? Yeah. And that is also where my number line is going on my graph. All right. Can you list all the numbers graphed in the example above? Can you list all the numbers that are bigger than 2? 3, 4, 5, 6. What about 2.1? No. What about 2.01? 2.0001. Can you list all the numbers that are bigger than 2? No. Can you physically list them? You could. No, you can't. Okay? It is no way to list all the numbers. How come? Because it's many. How many are there? Infinite. There you go. There are infinite amount. Meaning never ending. So I can't list them because they never end. There are infinite amount of values greater than 2. Okay, they go on forever. Oh, I did that in the wrong spot, didn't I? You were supposed to do that down here. This had to describe the numbers. My description should be all values greater than 2. I apologize. Helps read the directions. I didn't follow my own rules. Describe the numbers, so that's all the values bigger than 2. We cannot list them. There's an infinite amount. The inequality that represents that is x's greater than 2. Write the solution set that represents the graph above. So the way we write our solution set, we have this cool little bracket thingy. We're talking about my x's. So I state the variable I'm referring to, and then I say x's that are bigger than 2. So then I do the rule. So we do my variable, that is what I'm talking about, and then my rule of my variable. My solutions go with my x's, and it's all x's bigger than 2. Okay, that's how we write a solution set. All right, ready for another one? Yes. All right, this one. We have a number line. We have a circle. We have an arrow again. This time, how would you describe that dot or that circle? It is closed. Good. This is a closed circle. Notice it's filled in. So that means that the number represented by the endpoint, in this case 10, is a part of the solution set. Open is not. If it's not filled in, it's not included. Yep, and then this one, if it is filled in, it is included. Yep. So whatever inequality my last one came from, if I plugged in 2, it would not work. This one, wherever this got solved from, if I plugged in 10 to the original equation, the equation would work. All right? Write an inequality that represents the graph above. All right, so inequality. All my x's, it's something with an x and something with the 10, right? Are all of the x's on this arrow, are they greater than or less than 10? They're greater than 10. So my x's are getting bigger, so my alligator's going to eat my x. Are they equal to? No. Yes, because we're closed, so this one gets a line. Okay. Inequalities means not equals to. So we usually have an equal sign like this, right? If we just have symbols that don't have any lines at all, then we're not equal to it in any way, shape, or form. But if we have added that equal sign underneath it, that extra line, that's showing equal to and greater than, or equal to and less than. It shows both. So x's are greater than or equal to 10. All right, my solution set. Funny little squiggle. What variables are we talking about? My variable is x. And what x's are we allowed to have? Greater than or equal to 10. So see how the inequality is what I write in my solution set. Y is or equal to included in this solution set. What made us write that in the first place? Because we had a closed dot. Closed dot means 10 is included. A closed dot means that the 10 is included. Is it coming back? Yeah. Are we remembering? Yeah. Okay, good. This first little section is like a review, and then our next section we're going to do stuff. All right. Just like there are properties of equality, there are also properties of inequality. So we just solved equations, right? Adding both sides, subtracting both sides, multiplying, dividing each side, right? Yeah. We did those two equations where they're equal to. This is saying we are also going to be able to do that with inequalities. So even though my symbol has changed, we can still use those same properties. Okay? So if I have x's are greater than 5, can I also say x plus 1 is greater than 5 plus 1? Okay? Let's test it out. Let's use the value for x. Give me a number. 6. Sounds good. So if I'm going to use x equals 6, you can do whatever you want to right now. We're just testing the theory to see if it's going to stay true. So if x equals 6, is 6 greater than 5? Yes. So if I add 1, let's see if it stays true. So what is 6 plus 1? 7. What's 5 plus 1? 6. Is 7 greater than 6? Yes, so it stayed true. So am I allowed to add 1 on both sides? Yeah, I'm allowed to add 1 on both sides. So the same properties are going to be applied to our inequalities. If we add a number on both sides or if we subtract a number on both sides, as long as we do it to both sides, my inequality will stay true. Okay. So if we have 2x minus 1 plus 2 is greater than x plus 1, we can solve for x just like we were doing, right? We are just repeating exactly what we just did. There's just a different symbol in the middle. So if I have 2x minus 1 plus 2 is greater than x plus 1, What are we going to do first? There we go. Yes, ma'am. We're solving for x. Nope, we're trying to solve, see what all the x values could be. So I gotta move stuff over. Parentheses, so there are parentheses, so I should look there first. Can I combine anything in my parentheses? No. I can't do anything with it, but that is where I should look first. So I can't do that. What should I do? Yes, ma'am. Okay, the 2 on the outside, how can I move that? Good, yep. So now I have 2x minus 1 is greater than 1 minus 2, which is negative 1. Alex, what do you think we should do now? Then how about you move up? It's also in the book right in front of you. Looks like that's a great desk to choose. Kale, what do you think? What should we do next? There's technically 4 different answers right now that I can take. Tell me what to move. I need to get x by itself. We just did a whole quiz on this, on solving equations. Tell me what I can move over. Yes, I need x by itself. Okay, how am I going to move over my negative 1? Since it's being subtracted right now, how am I going to move it? There we go. We're going to add. Negative 1 minus 1 cancels out. Still have this guy. What is negative 1 plus 1? 0. Okay, so that cancels out there too. Now I have 2x is greater than x. Let's get those x's together. Dividing by 2 is not going to help me, because then I would just have x is greater than x over 2. So it's not going to help. It is not the answer because x is not by itself. I have 2 x's still. What am I trying to do? I'm trying to get more room. There we go. So I'm going to move this guy over. I'm going to move it. I'm going to bring it with the other x. This is new. I don't think we've done something like this yet. Okay. So I'm going to move the x to be with my other x's. So if I subtracted it over here, it's 0 now, right? Which is okay. 0 is still a number. 2x minus x is going to give me, or x, remember it's 1. 2 minus 1 gives me 1. So now I have x by itself. So what's going to solve this? Any x that is bigger than 0. Okay. Could it equal 0?
Yeah. Well,
No, it cannot. Okay. You could even test it. 2 times 0 is 0, minus 1, negative 1, plus 2. That gives me what, 1? If I plug in a 0 right there. And the other side, x plus 1, 0 plus 1 is 1. Is 1 greater than 1? No. So see how, that's why 0 doesn't work. They're equal to each other. 1 is not greater than it. So that's why we cannot say equal to. You could test numbers. You could test the number 1. You could test the number negative 3 and make sure that you did get the right thing. So there's a way to check yourself. Okay. So yes, we're going to move all the x's to one side and move all of my whole numbers to the other side. Next one. Consider the inequality 4 plus x minus 5 is greater than or equal to 10. Use the addition or subtraction property of inequality to solve for x. express the solution in set notation and graphically on a number line. So we're going to solve for x, we're going to write it in set notation, and we're going to graph it. Okay? So step 1 is to solve. So we have 4 plus x minus 5 greater than or equal to 10. All right. I see parentheses again. Can I combine anything in those parentheses? No, I cannot. So what's my next move? What are we going to do? Yes, ma'am. Yes, let's go ahead and add that 5. So now I have 4 plus x is equal to 15. Ooh, not equal to. Greater than or equal to. There we go. Four plus x is greater than or equal to 15. That 4 is in my way. Yes, Kale? Yes, good. We're going to subtract 4. Yep. Great. So we get x is greater than or equal to 11. Right? So we have solved for x, right? There's one part of my answer. Express the solution in set notation. So that's my squiggle, right? What variable are we using? We're using x, and what x's are we allowed to have? Any x that is greater than or equal to 11. So there is my set notation. And then graphically on a number line. So I'm going to draw my number line. Whoop. What's the only number I really care about on this number line? 11. So let's plot that. Smack dab in the middle. Am I going to give this an open or a closed dot? Close. I do mine above. Just because I don't like drawing lines on top of lines that are already there. Am I going to make this arrow go to the right or go to the left if my x's are getting bigger? To the right and the right. Yep, because they're getting bigger, right? Over here, there's 12, there's 13. Those x's are getting bigger. On the other side, you have 10 and 9. So if you need to put a couple of numbers on each side, you're more than welcome to. I need to show where my x's are getting bigger, so that's the 11, 12, 13, and on. Okay? Questions for me? All right. Consider the equation 4x plus 8 is less than 1 plus 2x minus 5. Same thing. Use the addition or subtraction property of inequality to solve for x. So there's step 1. Express the solution in set notation. There's part 2. And then graphically on a number 9. So there's part 3. So we have the same 3 things we have to do again. So let's solve it first. I can't do anything else without doing this. All right. I see parentheses. Can I do anything in those parentheses? No, I cannot. But I should always check. You ever got parentheses? Always check and see. So I can't do anything there. What should I do first? Subtract the 1. Good, Tyler. So those cancel. Over here, though, we have 4x plus 7. Good. Less than. Now I have 2x minus 5. So do we see how both sides have an x and both sides have a constant? What we want to do is get all of the x's together on the left and then all of my whole numbers together on the right. Okay? Well, I want to put my x's on the left and my whole numbers on the right. Let's subtract 7. Yes. I will show you. This gives me negative 12. There is a reason. Let's move my 2x over. How am I going to move that? Subtract it. So 4 minus 2 gives me 2. And last but not least, how is 2 attached to x right now? It's being multiplied, so what am I going to do to get rid of it? Let's divide it. So x is less than negative 6. Okay, if I did the other way, let me show you. You don't have to write this. I actually would prefer if you did not write this. Okay, let me show you what's going to happen. If you added the 5 over here and then subtracted the 4 over here, and then we divided. So we still get x is less than negative 6, but you see how it's written differently? So the arrow looks like it's pointing to the right, but that's not what we're going to graph because my x's are smaller than negative 6. So you can do it this way, but you got to really think about, okay, where is my x? Is it less than? Is it greater than? If you keep the x on the left-hand side every time, then the symbol is going to point to where your arrow is going to go on the number line. So that's why if we just always keep our x on the left, it's just going to help us. Okay, so you're not wrong with this, but you might do the next part wrong because you might get easily confused. Good question, though. All right, part 1 is done. Inequality. Part 2, express the solution set in set notation. So squiggle. That is not a good squiggle. Let me try that again. There we go. I know. They have like a real name. I just don't know what they are. What variable are we using? X. They're not called brackets because brackets are straight like that. They're squiggly brackets. All right, I'm using x's, and what x's are we allowed to have? Anything that is less than negative 6. Yep. All right, step 2 is done. Now let's draw my graph. So we have negative 6 is needed. It's always a good idea to do one below and one above. What kind of dot am I going to give negative 6? Is it going to be open or closed? How do you know it's going to be open? Because it's not equal to. So open dot. And am I going to shade my graph to the left or to the right? If I want to go smaller. To the left. Good. These are getting smaller. Right? And on my x-axis, isn't that true? The left side is getting smaller, the right side is getting bigger. That's what the number line is. The number line is the x-axis. Okay? And then here's my step 3. Woohoo! We done. Yeah, it was 3 steps. Solve, write it in set notation, and then graph it on a number line. With this problem. No, with this problem. Yes.
I remember you saying it, and I forgot. How do you know if it's open or closed?
So if it's equal to, it'll be a closed dot. If it's not equal to, it's an open dot. I know.
Can there be a less than or equal to one too?
Yeah, there's greater than, less than, greater than or equal to, less than or equal to. There's 4 possible symbols you can have. And then equal sign is the 5th. Okay. Of course, we got to make things fun and interesting. So let's put a word problem in here. Woo! You know how to do this. You know how to do it. We just did it, okay? We can pull out information. We can make an equation. Bless you. Only difference is we got to determine if it's going to be a less than or greater than sign. So Peter deposited $27 into his savings account, bringing the total to over $234. Write and solve an inequality to represent the amount of money in Peter's account before the $27 deposit. Okay, so he did something to bring his balance up. Do we agree? Yes, no, maybe so? bringing the total to over. So if it brings it over 234, was it greater than or was it less than?
Oh no, it was more than.
It's bringing it over. So something is going to be greater than 234. Whatever they did brought it over that amount. Does that make sense? See those keywords? Over 234. Okay. To deposit money, does that mean he's putting money in or taking money out? He's putting money in. Good. To deposit means to add money. What's the word of taking money out? Withdraw. Good. So if we're adding money in, do I know how much money I had to start with? Nope. So is that going to be my variable? Yes. So X is going to be how much money I had, and we're adding $27 to it. So X is the starting amount. What's up? Okay. Okay, so my original balance plus $27 took Peter over $234. Okay. How can I solve for X? Good, Landon. Good, Jacob. We're going to subtract the 27. So my initial balance was greater than what? 207? Good. So I don't know do I know the exact value of his starting balance? No, I just know it had to be more than $207. Could it have been equal to $207? No, because then when you added 27 to that, you would have gotten right at 234, and they specifically said it went over that amount, right? So it had to be his initial balance. Initial, word problems get word answers. Initial balance was greater than, there we go, greater than $207. Yeah? This does not have beat the test, correct?
No.
Okay. There's no beat the test for this one. Questions on this? No? Okay, I'm gonna